In my last full-length video, I took my workhorse Ender 5 here and I added an Ulti-Stick removable build plate. I have been really happy with that upgrade. It has done fantastic with every print that I've thrown at it. Now since then, it has made me wonder, should I go ahead and take the plunge and install a 32-bit mainboard in here to see if I'm happy with those results? In this video, I'm going to do just that. Bigtreetech has sent over their E3 Mini version 3.0 that I'm going to install in here and let you know what my thoughts are. Now, if you've got an Ender 5 Plus and you're checking out my channel as usual, don't worry, I've got you covered. I've got some Ender 5 Plus based firmware for this as well. So if you're looking for the upgrade for an Ender 5, if you're looking for the upgrade for an Ender 5 Plus, stay tuned. I'm going to cover everything you need to know right here on Kersey Fabrications. Let's get going. This video is sponsored in part by PCBWay. Thanks to PCBWay for sponsoring this channel, and stay tuned to later in this video where I'll tell you about all the different services PCBWay has to offer. Now jumping right into this video, let's take a look at the features of this board, compare it to 3 other options that you may be looking at. The first board on this table is going to be a stock board. Now the one I have popped up here is going to be the Ender 5 Plus stock or silent board. The next 2 I've got are the E3 Mini version 2.0, which is the last generation board, and the E3 Mini version 3.0, which is the one that I'm installing today. Then I'm also going to put up here the SKR2, which is a larger main board and the one that's the most feature rich, at least in this table. Let's get the processors out of the way first. First of all, you'll notice on this table, the only board that you'll find with an 8-bit processor still are the stock Creality boards on some of their printers, on some of their older model printers. And they're usually something in the ATmega family. And in this case, it's an ATmega 2560. It only runs at 16 megahertz and has 256 kilobytes of flash. The onboard steppers that it have, if it's a noisy board, if it's one of the old generation boards, it's going to be something like an A4988 drivers, which does not have silent step. And if it's a silent main board, you're going to find something like a TMC 22.8 driver on there. Now moving on to the Bigtreetech options, let's compare this new version 3.0 board to the previous version 2.0 board. Now looking at the processors, they're both 32-bit ST processors. But if you look at the version 2.0 board, it has what is considered a faster processor. It is an M3 running at 72 megahertz, whereas the E3 version 3.0 is an M0 Plus running at 64 megahertz. Now, will you see a difference in the performance of these two boards when you're actually running a print? The answer is probably not. The difference between these two chips are some of the instructions and a little bit of clock speed, but I don't really think that these are going to be a big difference in actual real-world performance. A bigger interest to me is the difference in flash size here, because the flash size is what holds your program, it's what holds your firmware. So the bigger the flash, the more features you can hold in that firmware. So you'll notice that the flash size on the new version 3.0 is a 512 kilobyte flash as opposed to the 256 kilobyte flash which is on the older model. Now both of these boards are sporting the onboard steppers, meaning that you can't swap them out, and these are TMC 2209s in UART mode, which does mean that they are programmable, which is pretty important when you want to change voltages or some of the other stepper parameters that are available inside of Marlin. So moving down the table, you'll notice the next difference is the controllable fans. We have one more controllable fan on the Mini E3 version 3.0, which is really nice when we want to turn off that chassis fan when it's not in use. Moving on down, the only other difference you're going to find is that we have a few more expansion options on the new board. It has a SPI expansion as well as an additional expansion I/O port. Now these are only going to matter to certain people that are going to be doing manual expansion to this board and probably won't make a big difference to the average user. Now looking at the cost, you see that the new board is cheaper than the old board. Now that may be because they went with a cheaper ST chip with a less expensive core. That also may just mean that some of the other components have dropped in price, or potentially that Mini 2.0 has gone up since it originally launched, and there aren't quite as many of those on the market. Either way, the version 3.0 is definitely a really good bargain. Now let's take a look at this new board side by side with its version 2.0 older brother. Now overall, you'll notice that these two boards are almost identical, at least in terms of layout. Most of the slots are in the same place, and most of the electrical connections are pretty much exactly where they were on the previous generation. The first thing that will stand out to you, of course, is that they've integrated the heatsink into the main board. Now, practically, will this do any different than it did on the previous generation? Probably not. I don't imagine that this heatsink will be much more effective than the previous generation. In fact, a lot of people have brought up that you actually may want to cool this on the back, but that's not really an option, at least in terms of the way most people are going to mount this into their system. Electrically, they talk about in their documentation that the thermistor inputs are now protected from short circuit, which is really nice. They've adopted a micro USB slot instead of a mini USB slot, which to me isn't very much of an upgrade, because I find that the mini USB slot is actually sturdier than the micro USB, but maybe more people have micro USB cables laying around. Now, just to be thorough, let's make sure we cover what you might be missing or gaining if you go with a E3 mini board instead of something like an SKR2. The SKR2 is definitely a larger board, and I think that's the first thing to point out, is that an SKR2 is going to require custom mounting in most Creality printers, probably most printers that aren't even Creality. It has a larger custom footprint, and the external ports are going to be in a different spot than a stock Creality board. While an E3 Mini is going to fit most Creality printers, it's going to have the sockets exactly in the same place. It's a plug-and-play replacement for a Creality board. That's going to mean a lot to people, particularly if they're not looking for a lot of hassle, so just keep that in mind. Now, looking at the specs of the two boards, you'll notice that in SKR2, first of all, it has a much beefier processor. It has a Cortex M4 running at 180 megahertz, which is as you can see from the specs, it is a higher level processor, meaning more instructions, more features, and it has over double the frequency. Now again, are you going to see that pan out in prints? Are you going to be able to get faster speeds? Well, a 3D printer is a complicated machine, and not everything comes down to the performance of your electronics. It's a mechanical beast, and it has to all be balanced out. So keep that in mind if you think that's going to directly translate into performance. Next up, you'll notice it has even more flash. If the Mini E3 2.0 doubled the flash when it became a 3.0, the SKR2 doubles it again with a full 1 megabyte of flash, which is just absolutely fantastic. But I do want to comment that it may not actually be needed, because I don't know if I've ever built a Marlin image that's over 512 kilobytes. So just keep that in mind. So going down the rest of the list, you'll notice that an SKR2 does not have onboard steppers. This means that you can put whichever steppers you want on the board, or upgrade to new steppers later if somebody releases something new and shiny that you want to replace it with. Now, obviously, larger footprint board, we can actually hold another stepper driver, and this is going to be the main appeal to having something like an SKR2, which has at least 5 stepper drivers. Now on a larger printer, something like an Ender 5 Plus, you're going to be able to do a left-right alignment of the bed automatically inside of Marlin. That's not something that you can do with an E3 Mini. Now for something like the Ender 5, which we're upgrading today, that's not going to be important to you. This only has 1 stepper driver in the middle. So when we're talking about the Ender 5, that extra stepper driver just isn't important to you unless you had planned on adding a second extruder. Now continuing on, you'll notice that it does support an extra hot end. That is, of course, if you're not using it on a large printer like an Ender 5 Plus. It also has an additional 2 always-on fans and an additional filament runout sensor, obviously, for that second extruder. Now, it doesn't have a dedicated EEPROM on the board, which, if you're not familiar with it, that's where you can store all of your printer settings. That's not a big deal if you have a big enough flash chip, and this one does have flash to spare. It has that full 1 megabyte of flash, and we can actually store our settings on flash instead of EEPROM, and it'll work just fine. Moving down the rest of the graph, we have a lot more expansion options on something like an SKR2. So be sure to check the table if you had planned on a lot of extra expansion. But again, like I mentioned before, a lot of those extra expansion features just won't be used by your average user. Now, looking at a cost comparison between the SKR2 and the Mini E3 version 3.0, you'll notice it's quite a bit more expensive, in the neighborhood of about $20 more, which not a lot of money, but comparatively, it's about, what, 30% more expensive. So if you're not going to use any of those extra features, if you don't want to go through the hassle of the additional steps to upgrade, it's not going to be worth it to you. Now, in my opinion, if I'm doing an upgrade of something like an Ender 5, the E3 Mini version 3.0 is a no-brainer. It is a drop-in replacement. All you've got to do is put it in the machine, do a firmware update, and you are ready to go once you finish your tuning. Now, on something like an Ender 5 Plus, the E3 Mini, in my opinion, is for someone that doesn't want to go through the hassle of the extra upgrading, the hassle of cutting holes, the hassle of printing out an adapter plate, all of that I've shown in previous videos. Now, if that kind of extra upgrade work is just not it for you and you just want a drop-in replacement, the E3 Mini is going to be a fantastic choice. What you're really going to miss out on, in my opinion, is just that Z alignment feature that you're going to get by adding that extra stepper driver to run your Z's separately. Again, if that's important to you, if that's not important to you, that is your personal decision, and you'll have to decide which way you want to go. So now that I've gone through all the features and tried to help you make a decision on which board might be best for you, it's time for me to go ahead with this upgrade. Now, I've done in my previous videos, I am going to walk you through the schematic of this real quick so that you know how to read a schematic. So when you go to upgrade your machine, you can do what I've done, print out a schematic, hook everything up really easily, and know that you've done it properly. So I'm going to move down to the table, show you my schematic, and we'll walk through it. So here we are with the schematic of the Mini E3. This represents this board you see right here. Now, I'm going to be using the schematic because it's already labeled and it's laid out for us, but it is referencing this physical board at this orientation. So first of all, down here in the lower left, we have the power. Now, if you're unfamiliar with schematics, we have GND, which stands for ground. This is going to be typically our black wire. And we have 1224 volt. This is going to be the input voltage, and that is typically going to be our red wire. So this power connector right here, this is where we're getting power from our power supply. Next up, these two larger connectors. This one's going to provide power to our heated bed. This one's going to provide power to our first hot end. Now, you'll notice here we have that 1224 again, just like this. So this is going to be our red wires on both of them. Now, these are labeled PC9 and PC8. Now, these PC designations, similar to PC6, or even I think there's a PB over here somewhere. Now, these represent lines that go to our processor. This means that these are controlled lines, things that our processor has control over. But in this case, since these are labeled 1224, we know this is red, and since this is not 1224, we know that this is going to be our black wire in this case. So red and black, red and black. Now, moving over, these three headers right here are going to be our three fans. Now, fan 0, anytime you're working with Marlin, fan 0 is going to be your first part cooling fan. And fan 1 is going to go to your hot end cooling. That leaves fan 2 on this board, a controllable fan, going to the one that's usually cooling your main board, the one that's attached to probably the bottom of your chassis. So on this case, again, we have these 1224 lines on all three of them, and then we have these PB lines. Now, down here we have this one right here, this SWDIO. Now, this is for software debugging. This is not important if you are not developing software, if you're just hooking up to your printer, so you can ignore this one. Moving on to these next one, we have this PS on and power detect. These are going to be for specific power options that we're not going to be covering in this video, so you can ignore these. This TFT plug right here, represented by this TFT plug here, this is going to be the 5-pin connector if you are using something similar to a TFT 35 from Bigtreetech. Now, if you're going to be using your stock display like I'm going to be using today on your Ender 5, you can ignore this header. It's not going to go anywhere. But if you do have that 5-pin touchscreen connector, make sure you hook that up right here. Now, these right here, these are our 3 end stops for our X, Y, and Z. Now, the thing about end stops is left, right, plus, minus, black, red, these don't really matter on these end stops typically. So for X and Y, it's not going to matter. Now, Z on our Ender 5 isn't going to matter either in terms of which way you plug this in. But if you are hooking up an Ender 5 Plus, the polarity of this plug is going to matter if you are using a BLTouch. This one has the ground and the PC2. Now notice this one, calling out ground. So if you are using a BLTouch, the ground is going to be your black and the PC2 is going to be your white. But again, on the Ender 5, all 3 of these, the polarity does not matter. Now these TH plugs here, TH0 and THB, these are going to be your thermistors. These are typically your white wires coming from your hotbed and coming from your first hot end. These let your board knows what the temperatures are of those 2 areas of your printer. Those plug in right here. Now, no matter which display you're using, this is going to be the main connector for the Marlin side of that display, for the text mode side of that display. So if you're using a TFT35 from Bigtreetech, or if you're using the stock display, this is where that's going to plug in. Now, right here we have what is called Z probe. Now, if you have a standard Ender 5 like I have, I do not have a Z probe. I do not have a BLTouch plugged in, so I can ignore this. But if you do have a BLTouch, this is going to be the pin assignments for here. Now, these 3 pins at the bottom, the ground, the power, and the PA1, this is going to represent where you're going to plug in the 3-pin wire from your BLTouch. Now, these colors vary depending on your model of BLTouch. I will include a graphic up here that shows a couple of different options for this if you have a BLTouch, but that's where those are going to plug in right there. Now, if you have some NeoPixel lights, again, not covered in this video, those are going to plug in right here, and you'll have to set up Marlin to control those. This is that SPY expansion. If you know what that is, if you plan on using it, that's where you'll find it. Then we have an extra I/O ports, an extra USB. These are all those expansion ports I was telling you that we are probably not going to be using unless you know what you're doing with those. And the final plugs that we need to worry about are these up here at the top. This is where our stepper drivers are going to plug in that go to the various parts of the printer. These are labeled pretty easy, not hard to follow. XM, YM, we have 2 ZMs, ZAM and ZBM, and EM. So X, Y, Z. Now if you're running an Ender 5 like I'm going to be putting this into, you're only going to use one of these plugs, and electrically it doesn't really matter which one you're using, so I'm going to use the first one. Now, if you have an Ender 5 Plus you're plugging this into, this is going to matter a lot more. Now, if you're hooking this up to an Ender 5 Plus, you are going to be using these plugs, and again, it's not going to matter which one you plug into where, just plug them both into these ports right here. And then right here, this is going to be where your extruder plugs in, and you are all set. Now it's time to take the theory and turn it into reality. Let's get our board installed in our printer. Now, before we get too far into the physical installation of this board, let me tell you about this video sponsor, PCBWay. Now, PCBWay, as you probably know, is a terrific place to go and get your PCBs manufactured. Whether you just need the boards or whether you need complete assembly, they offer those services. But did you also know that PCBWay also offers manufacturing services such as 3D printing, CNC machining, sheet metal fabrication, and injection molding? So no matter what you are trying to assemble, no matter what you're trying to build for your project, PCBWay can probably help you make it a reality. So be sure to check out PCBWay for all of their various services, and thanks to PCBWay for sponsoring this video. All right, Ender 5 ready to go here. Let's lay it on its side so we can get to work on it. Now, one thing, when we are laying this on its side, let's make sure that we don't take anything that's hanging off the edge and use that as a support. We don't want to rest the entire weight of this machine on any mechanical component. You could damage it. You could just throw it out of whack. You don't want to do that. So if you have a table like I have here, you're just going to want to hang it off the side and use the bars as your support here. That way, again, you're not damaging the printer while we do this mod. Let's get up close. All right, to get going, let's just go ahead and get the 4 screws off the corners here. Now, as we get the cover off here, we need to be very careful because this wire right here is going to still be connected to our main board, and we will need to be careful not to rip that out, but that pulls off the main board really easily, and then you are ready to go. Going through what's in here, if you've never opened one of these up before, this is your main power supply. This converts your AC wall power to the DC power that all of these electronics uses. And you'll notice that we have different wires. Some of them are coming from your plug from your wall, and some of them are going from the power supply to your main board or other components of your system. So what we'll be changing out here is this board right here. Now let's get up close. I'm going to show you what I've got here, and we will go through the modification. All right, so one thing I want to mention now that we're up close, let's take a look at one of these connectors. I'm going to come in here right here, which is the power supply connector, and I'm going to pull these off. This is the power that goes to the main board. Now, one thing I'm going to mention briefly in this video, but I'm not going to belabor because I have covered it in other videos, is that the tips of these wires are bare, and yeah, these actually have been tinned, meaning that they have had solder applied to them. So this isn't the way that this should be done. This could potentially be a fire hazard. Now, there's some disagreement in the community on how dangerous this is, but I would be wrong not to mention it here. So if this sort of thing concerns you, if you are worried that this could potentially be a problem, do your research. There are a lot of videos on it. I've included a link to a video on my channel that talks about it. But if you're worried about it, what you'll need to do is add ferrules, which you can see right here. This will correctly install these wires into this main board. It's an inexpensive and easy thing to do and could save you some problems in the future. So I just wanted to mention that before we got started. Now, the way we're going to do this installation is we're going to remove all the wiring from this main board, move it out of the way, remove this main board, install the new one, and then we're going to reinstall all of the wiring, and I'm going to show you which wires go where in the new main board and make sure all of our polarity is correct as we go along. So as we remove these motor wires, which are the easiest to get done, now keep in mind as you're removing these, there may be hot glue on these because that's how they were installed at the factory. If that's the case, you're going to need to grab a pair of pliers or a screwdriver or something and very carefully remove that glue from the connector because it's not going to come off easily without it. So just be careful as you're doing that. I've already removed all the glue from my connectors, as you'll see here. Now, ideally, you'll want to pull from the connector and not from the wire. It could save you a lot of headache in the future if you're pulling the white connector and not pulling the wire itself. Now, this whole bundle pulls out of the way. Now you can remove the fan header right there. And these two wires are tricky. You'll notice that they have given us no labeling whatsoever as to which one goes to the hot end and which one goes to the heated bed. So we need to look on the board to see which one is our heated bed and which one is going to our hot end. Now, from the look at it on my main board, I believe the one in the corner, the one furthest this way, is going to be the one that is for the hot end, and the one on this side is going to be for the bed. So what I'm going to do, I'm going to go grab my label maker. I'm going to label both of these so that I don't mix them up in the future. Okay, all labeled up. Now let's get these out of here. So we can go ahead and pull out the ribbon cable that goes to our display. And then on the last ones here, these are all screw in. So we just need to loosen up these posts here. We can do them all at the same time. All right, now let's talk about what each one of these go to real quick as we're pulling them out. So on the left here, we have these two wires. Now these are both red. These go to our hot end heater. And the way we can tell that is because generally the hot end heater wires are both the same color. But the next two are big, thick wires. Most often these are going to be to our heated bed power. And then these two little thin ones are going to an always on fan. So that fan right there is going to be going to our hot end fan, which in this configuration is always on. Now our biggest problem here is that these two are actually going to need a connector for when we're actually connecting it to our new main board, because if we want it to be controlled, they need to go into one of these, and so we're going to have to get that fixed and put a connector on there. That's going to be your probably most difficult thing to do here, is to get a connector on there. So this board will come out of here pretty easily. We've got 1, 2, 3, 4 screws, and this will pop right out. Make sure you're holding something metallic as you're touching this main board. You don't want to blow anything up with static. I don't expect you to have a wrist strap, but if you do have a static wrist strap, this would be a great time to be using it. There we go. Now we're done with this board. You can set it aside, save it in case you need a backup in the future, in case this doesn't go well and you're going to need to just put that back in there. Make sure you just keep this around just in case you need it. So before I put the new board in, I'm going to be working in this area. I don't want to damage the new board in any way. So this is where I'm going to go ahead. I'm going to show you how I'm going to put a quick new connector onto here so that we can plug it into a fan header. And then I'm going to go ahead and add ferrules to the rest of my connectors so that I'm safe and don't have to worry about any sort of fire hazard or electrical damage. Next up, we need to put a connector on this fan wire because it's a bare wire as is. Again, though, we are going to need to be able to cut it off a little bit because they are soldered. Technically, we don't have to do this because we're actually going to be soldering them back, but I just think it's cleaner. Don't need quite as much taken off of this one, so I'm going to adjust my stripper to be a little bit shorter, probably closer to the 1/4 of an inch mark. I'm going to take off a little bit. That looks good, nice and clean. And a 1/4 inch there. I'm going to leave those. Actually, we can, just as before, just twist a little bit just to make them easier to insert. And then I like to use these pre-made ends. It saves me a lot of time. Now I can of course make these. I have all the tools and connectors. I don't like making them though. They're a pain in the butt. So these save me a lot of time and they're not too expensive because I really don't go through a lot. Link in the description. And here I don't need this much wire, so I'm going to go ahead and cut off a decent amount of it. Then I'm going to strip the same amount off of these as I did the others. All right. I've shown these before. What I have are these self-sealing solder and heat shrink in one. And now these things are dual purpose. Number one, they solder your ends together. Number two, they also apply the heat shrink. And number three, just to add one more, it actually does a really good job of gluing together your wire. See these white pieces on the end? It glues together your wire and makes actually a stronger connection than it would be if it was just heat shrink and solder alone. It's not going to matter on something like this, but might as well. So I'm going to go ahead and do the red one first. I put it on this end, and now the wire end is actually going to be right under the center of this where the solder is. Let's get that under there. All right, let's get this side in here. That works fine. I should just sort of be able to push these together a little bit. Make sure they are good and overlapping. Let's get the black wire out of the way as much as possible because I'm about to throw a flame at this. Make sure all the other wires are out of the way. I'm going to heat this up a little bit too much. We got to get that little bulb in the middle to start to melt. Obviously you can use a lighter for this, you can use just a heat source. This works for me. Alright, that one's good. That bulb is melted in the middle and both of the sealants have melted here. Alright, while that cools just for a second, we're going to start the next one. And we'll be good to go on all of our connections and we can start installing the board. Alright, so now let's get the board installed now that we have all of our connectors ready. So obviously this end down here, which has the USB connector and the SD card slot, that is going to go to the outside of our chassis, and there'll be openings over on this side for both of those connectors. Now we just need to reinstall the 4 screws that came out of here. I like to do the center one first. It's convenient and it kind of holds the entire board where it's supposed to go. Don't install it all the way though, because you need a little bit of movement in case something doesn't quite line up correctly. And then make sure we get all 4 of these tightened back down. All right, now it's just time to reconnect everything. I showed you the schematic before we began, and we're going to just use that to make sure we line everything up during the process. So I will take my schematic just like here. I know you can't see that very well, but I'll line it up with the board. So the small connectors up here and the motor connectors are down here. You can start wherever you want. Sometimes it's more convenient to start down here and work your way this way. I think that's what I'm going to do, and then I'm going to do the bottom down here. So first up are the 2 thermistors. Hot end 0 goes first, and then hotbed. Next up, we're going to do the Z end stop. Now, obviously, if you've got a BLTouch, this is going to be a little bit different, but hopefully you'll be able to figure that out. I'll have a schematic waiting on you to help out with that. So there's Z, and then Y, and then X, of course. There you go, you can see those. Next up, we are going to do the fans. So first up down here is going to be fan 0. So that is going to be actually our part cooling fan, which is going to be these nice colored ones. And then next up is going to be our fan 2, which is going to be actually our controller fan, which is on the cover. Next up, we're going to do the hot end fan, which is going to be fan 1, which is going to be the one above it or below it, depending on your particular orientation. We don't have a PS on or a power detect, so we're not going to worry about that. We're actually not installing a TFT35 or one of the Bigtreetech displays, touchscreen displays, so we're not going to worry about that one either. We don't have NeoPixels, so this one's not of concern to us. We don't have a filament runout sensor. We don't have a Z-probe connector, so that's not a concern to us. Now we can go ahead and hook up our display, which should go right here. So we're left with our heat bed, our hot end, and I did forget to put the ferrules on their main power, so I'll do those real quick, but that'll be it. But we can go ahead and do the motors while we're at it, and these are all labeled, so that's Y, so that's going to go in this spot right here. That's Z. We've only got one Z on this printer. I'm just going to put it in the first one. This is going to be extruder. That's E. That's going to be the one on the very end. And then we have this one right here, which is X. And that one is going to go right there. Since the connectors on these 2 are already done, let's go ahead and do them. E0, that's extruder. So that is going to be these 2 wires that we have put black ferrules on. Those are going to go in the furthest ones. And then our hotbed is going to go on this side. Polarity does matter, at least on the hotbed, because you can see that they've made the wires different colors. So let's make sure that the connectors are down so that we can insert something into them. I'm going to actually do the hotbed one first just because of ease of installation. Hotbed minus comes first and then plus. It's going to be a little tricky to get in here. You could have installed these wires first if you wanted to, before we installed the board, but I don't think it's necessary. Tighten those down a decent amount, but not over tightening, and definitely don't damage your board in the process. Plus goes on that side. So again, pay attention to polarity. Minus on this side, plus on this side. And then for our hot end, we don't have to worry about polarity because those are the same color. Now we can add the last 2 wires back. We're going to put the black one, the ground, on the top. And with all of that tightened down, all we can do is do a little cable management so that things look a little bit nicer in here when we close it up. Okay, now if you want to be super cautious, you can wait until you power it up to put this bottom panel back on. But if you want to throw caution to the wind, let me go ahead and show you how to hook it up. So here's my bottom panel. Here is the wire that connects that bottom panel fan. We're going to go ahead and connect that to the fan 2 header, so that goes right up there. Then this should close up fairly neatly. Screw this back together, and I'll see you on the top side. And one final thing, I know someone is going to ask me in the comments, so why not throw it into the video? Hey Chris, what if I want a touchscreen display? What if I want one more upgrade? I want a nice touchscreen display on this printer. Well, all you'll need to do is purchase one of these Bigtreetech TFT35 and make sure you get the Dash E3 version 3.0. The Dash E3 has this particular format which puts your button down here instead of on the side. Now this should be a drop-in replacement right here where the existing one is, and there should be no problem with you upgrading to a touchscreen. And all you're going to need to do, run your EXP3 just like you're going to find on this display up here. Run that to your board, but also you're going to want to run your RS-232 to the board, to that 5-pin connector I was showing right here. And the reset pin is going to be the one that is all by itself. So that should be pretty easy to set up. Just wanted to mention that in case you want a touchscreen, or just in case you want a text-based display that also does a whole lot of different colors. All right, so the machine is back upright. I've done some just basic power on testing, make sure nothing smoked, make sure everything seemed to at least boot up correctly. We are to that point. So now it's time to take my firmware, which is going to be available in the description, take it, name it firmware.bin, and put it on the SD card. Once we've got that, we can then insert it into the main board, which is down front. I've noticed on this board, it's now a friction fit SD card slot, which means it's not going to pop in and pop out like they traditionally do. This one's just going to friction fit in. And as usual though, it goes upside down into the slot. So let's go and put that in there and then cut on the machine. Now you're not going to really see anything when this powers on and does the flashing. It's actually going to be flashing in the background when it first turns on, and then when it comes up, you'll see it up on the screen with probably the Kersey Fabrications information on there, and then you'll know you flashed it correctly. And then you'll see it power up, and the Ender logo, KF, meaning it's mine, and the version number, T093. And then when you see this screen, what it's saying is basically you have a new version of firmware, and because of that, it's got a new set of settings it needs to initialize. And so what we're going to do, we're going to go ahead and allow it to do that and reinitialize that EEPROM correctly. That should take a second. It beeps, and we are ready to go. Now, on the first screen, what we're looking for here, we're going to want to make sure both of our thermistors are showing that they have temperatures. That means that those are hooked up. Now I'm going to back out and I'll give you a quick checklist of what to go over to make sure everything's working. So with the firmware installed correctly, it's time to go through a short checklist before we can actually do our first test print. Number one, make sure that the printer is working the way it's supposed to. So we want to run through a home cycle, make sure that it actually homes the printer correctly. Number two, we are going to want to make sure that the bed heats up properly, and then the hot end heats up properly. Now while we're doing that, we're going to want to check some of the fans on the printer as well. With the latest firmware and these new boards which have all computer controlled fans, fans are only going to cut on when certain things happen. So for example, the hot end fan isn't going to actually turn on until the hot end reaches 60 degrees Celsius. And the fan on the bottom of our controller down here isn't actually going to turn on until we actually move the motors. So if you'll notice, everything's very quiet right now. When you're not using the printer, you should have total silence, which is fantastic. But if you're checking to see if everything's working, you'll need to move the motors to check this one, turn it up to above 60°C to check that one. Now from there, if you saved off any of your settings, whether you cut and paste them from your terminal or whether you actually just wrote them down so that you would have them, it's time to actually go into the printer and actually set those back up. So whether you saved your steps per millimeter for your extruder, your Z, X, Y axis, or whether you saved any of your other settings such as your PID tuning. Now, once you've restored your settings, make sure you save them and then go through a couple of last minute things such as possibly re-PID tuning your bed and or your hot end. Once we've got all that done, it will be time for our first test sprints. So that's what I'm going to do now. I'm going to do all those things I just said without reiterating, and then I'm going to run my first test print, make sure everything is printing accurately, and then I will print a full model to make sure that I'm happy with the quality. So let me do all of that, and I'll come back to you guys in just 1 minute with the results. All right, the test prints are all done. Let's take a look at what I have here on the table. Number one, these green prints over here, these were just to tune the printer to make sure I was happy with my settings, and it's a new main board, so you have to get all that tuned in correctly. Number two, I printed just a handful of prints here just to make sure that the printer was printing as expected. So let's see what I've got here. On my left, on your right, I have, first of all, I printed 3 of these single-walled containers. This was to tune my flow correctly to make sure I was getting just the right amount of filament coming out of that nozzle. And then second of all, I designed this new model. It's just a quick test model just to make sure I was happy with the dimensionality of the printer, to make sure 100 millimeters was 100 millimeters in each direction. And I've got a little bit of a 10 millimeter height just to make sure I was happy with the Z dimensions. Once I had all those tuned in, I wanted to make sure, am I getting the prints I expected? So first of all, a quick vase mode print will check my overall flow rate. I did find, I think on this one, there was one small little missed extrusion, or something didn't stick quite the way I wanted it to. But other than that, the print is very, very clean. This print right here from Clock Spring 3D turned out really, really nice overall. Then I went to this amazing dragon print, Mecha Dragon print from Hex 3D. This is when I pulled it from him. I wanted to make sure, how's it printing? Are my prints strong? And dimensionally, are they printing well enough to print something flexy and have it turn out really well? Now this Polymaker filament that I printed this with, this is their Silk Silver, just turned out great. It's a great metallic print. And actually the only problems at all on this print that I see are the fact when I got to the very tips of both of these parts of the bodies, well, they came off the bed just a little bit. And so as they were printing, they were wiggling around a bit. And so those didn't print so nice. But the rest of the print, very, very nice. It's a strong print. It's holding up really well. So I'm really happy with overall how that turned out. This can be fixed by slowing down the printer a little bit, or just by making sure I have a little bit better bed adhesion, maybe with some glue sticks in just the right places. And then finally, I did want to print a bust. This bust is from Photos Mint, and it turned out really, really nice overall. Again, I think I saw a little bit of under extrusion on here in certain parts of the print, but overall it has fantastic texture. It got all of the details just right, and the layer consistency looks really, really good on the bottom of this print. So overall, very happy with this upgrade. I think that this was a fantastic, easy drop-in solution for this printer. I might be able to get some more speed out of this printer. I definitely add a lot more features to this printer using Marlin. And so overall, big success in this. So if you're looking for a fantastic new drop-in board for your Ender 5 or an easy drop-in solution for your Ender 5 Plus, I think that this is going to be a great solution. Now, before I tell you about the firmware options I'm going to have for you, let me send out a few thank yous to the people that made this video possible. First of all, the makers and designers of these prints, absolutely phenomenal. All 3 of these come from Patreons that I support. We've got Clock Spring 3D, we have Photos Mint, and we have Hex 3D. All of them terrific modelers and ones you should check out and possibly support yourself. Let me also, of course, thank Bigtreetech for providing the board for this video. Again, they provided the board only, nothing else exchanged hands for this video. And finally, let me thank PCBWay for providing the financial sponsorship for this video. They have been fantastic in supporting this channel. And finally, of course, let me thank my Patreon supporters. These are the folks that keep this channel running video after video. They're the ones that keep these free firmware drops coming to you guys. So thank you to them for providing that. Again, if you're interested in supporting this channel, Patreon is the best way to do that. And they're the ones that always get my firmware drops first, and they know what is coming up on this channel ahead of time. So if you're interested in supporting what I do here and getting a little bit of extra stuff early, be sure to check out my Patreon. So about that firmware, what am I about to release in conjunction with this video? Well, obviously you're going to get the firmware for this board on this printer right here, and I'm going to be releasing 2 different versions, the one without the BLTouch and the one with. So if you have either one, be sure to check out the description for all of that information. Now, obviously, I support a lot of Ender 5 Plus users, so I'm also going to have an Ender 5 Plus release for this board. So if you have an Ender 5 Plus, I've already tested it myself. It works fantastic in the Ender 5 Plus as well. So again, check out the description for all the information on that board. And while I was at it, I went ahead and had to upgrade to 2.0.93 anyway for this new main board. So might as well do a complete new release for all of the previous boards I've supported. So if you've ever downloaded any of my other firmware, please go check out the description again for all of those releases. There's a full list of all of the Ender 5 Plus boards that I support there, and now they are all upgraded to 2.0.93. So here we are at the end of this video. If you are still with me, thank you for watching to the end. And if you haven't done so, like this video, please leave a comment on what you thought about everything I talked about here. And if you haven't done so yet, you're new to the channel, hit that subscribe button. That is what keeps those numbers up for me, and I really appreciate all the support. Thanks again. My name is Chris. This is Kersey Fabrications, and happy printing, everyone. I will see you next time. And I added this awesome Ulti stick. So in my last full-length video, I took my workhorse Ender 5 3D printer, and I have been super happy with that upgrade ever since. Okay, do that. Full upgrade of the 32-bit mini E3 Okay. I've been super happy with that upgrade. Now, I've been on to what you find in a standard Ender 5. We want to make sure that we don't frack, and then get the new board installed, and then we'll start hooking things up. What is the mini E3 going to bring? That's what happens when you try to talk too fast, boys and girls.